Okay, hope you have a good rest.
Hello.
You start.
Yes, and you can come here a bit later. Better.
Okay, let's go to the terminology. Right, the terms that you're supposed to know. Let's just go back again. Right, the first point that you need to know is that point there, principal focus. Right, we'll define it in a while. Then the P is called the optical center. It's the point where the light passes through without deflection. Right? Okay. The light can pass it from here without deflection, without refraction, sorry. Or I can pass from here, go straight through without refraction. Others will be reflected. And principal axis is a straight line which passes through the center of curvature of the lens. Okay, so this straight line passing through the center of curvature and passing through the principal focus. And from the principal focus to the optical center is called the focal length. It's the distance from the principal focus to the center of the lens. U, the object distance. That's the object distance. Object to the center is called U, object distance. V, image distance from the center to the image. That's your V. Right? Some country they use P and Q. But Malaysia, we tend to follow the British U and V. Okay, let's define the principal focus. Right? These are parallel rays. It converges to the principal focus there. And that is your focal length. Right? So principal focus, the point on the principal axis where the incident ray, these are your incident ray, which are parallel. Right? The key is parallel and close to the axis, converge. Okay? These rays are parallel and close to the axis. It converge to this point. So that is your principal focus. If it's a concave lens or diverging lens, like this one, right? The point on the principal axis where the incident ray, which are parallel and close to the axis, appear to diverge. Right? So that is your parallel rays. They appear to diverge from this point. Principal focus. This one is converge to the focus. Principal focus. This one, yeah, it diverge. But all these diverging rays appear to diverge from this focus, principal focus. And the distance from the principal focus to the center is the focal length. Stop me. Anything not clear? Right? Drawing ray diagram. There's your STPM work. Right? F is your principal focus. O is your optical center. That's your object. Right? First ray passing to the principal focus is undeflected. Right? That's the easiest one. Okay, principal focus not deflected. Second ray which is parallel to the principal axis will be deflected by the lens towards the principal focus. So it's parallel to this axis there. After it passes through the lens, it goes through the focus. Remember, it's thin lens there, so you don't need to show, the slight deflection in the intersurface there. Go that way. Third one, ray that pass through the principal focus appear parallel to the principal focus after emerging from the lens. Okay, so that's the ray pass through the principal focus. After it passes through the lens, they go parallel. So these three rays must pass through a point. But for construction, you can choose any two. Good enough already. The third ray is just to check whether your construction is right or wrong. And that is your image. I. Any comment? Anything still not clear? Okay, Let's look at
last slide just now. Okay, ray passing through the optical center is undeflected. Oh, the blue one. Okay. Ray which is parallel to the principal axis will be deflected by the lens towards the focal point F. Okay. Ray that pass through the focal point appear parallel to the principal axis after emerging from the lens.
Okay.
Okay.
Memory work, nothing much. Know how to use it. Okay, let's look at very far away. Right, where the object distance is more than 2f. Right, that's your 2f. The distance is 2f. That's your f. Okay, so object anywhere greater than 2f. Any two rays can be used to locate the image. Right? The easiest way to use the blue one, passing through the optical center is straight through, that's all. Then the next ray is parallel to the axis. Then after it pass through the lenses, it will pass through the focal point or principal focus. And that's your image. Okay, so we can observe from our drawing, image is real, right? What does it mean by real? Yep, what does it mean by real? Trini, what does it mean by real?
Real means that means the what's that? It's not that means you can see the image lah.
No? You didn't study or revise your note properly. Right? Object can be a pin. You put a white paper called a screen here. You should be able to see the inverted pin here. Okay, that's what I mean by real. It can be formed on the screen. And then this one is upright. Right? This is called inverted. And then this is smaller. We call it diminished. And the image distance is between f and 2f. Right? Where do we use it? Camera lens and lens in the human eye. Right? Where this is just a short distance, that's all. Okay, now we shift the object to 2f. Right? Object distance is at 2f. Same. That one will go straight through the easiest way. And parallel to the axis. After reflection, pass through the focus and draw your image. Your image should be 2f there also. Right? Image is still real, inverted, same size as the object. Image is at 2f. Right? Used in your photocopier. Okay, anything that you want to ask?
No.
Okay, now let's go further. Okay, formation. Just previously is at 2f, now it's between f and 2f. Right? F and 2f, that's the object. Same. Right? Just only two rays. The easiest, as I say, use a ray that pass through the optical center. It just goes straight through. And parallel, after reflection, pass through the focus. And then that is your image. Image is still real, inverted and magnified. And is greater than 2f. Right? This is your 2f. Greater than 2f. Right? We just use in projector lens as a projector. Either overhead projector or the modern projector there. Or we use in microscope. Okay, anything not clear?
Nah, clear. You just have to memorize, right?
Make sure you do your homework. You should, I think we should finish this Saturday already. If you don't do your focus, I think you will be in trouble already. As it is, I can be honest with you. We are in trouble already. Right? You have phobia because you have not been studying your work. Then you look at your question, you don't know how to answer. Right? So tomorrow, whether you have your worksheet or not, I don't know already. I will carry on unless you want to cancel the class. Okay, as I say, 2 rays enough already. Just use the one that pass through the center. Right? Same thing. No point in drawing the bottom one.
Then can you have the class on Tuesday, please?
You want the class tomorrow?
No, because Tuesday is Thaipusam, so I'll be more focused. Holiday, what? If you don't mind.
So you don't want tomorrow's class?
No, tomorrow replace it to Tuesday. That's what I'm trying to say.
Tomorrow,
Yeah.
based on Tuesday. You are
Yeah,
not going.
Tuesday is a holiday.
Yeah, I know, but you're not going anywhere, man.
Yeah, no. Can't they cancel the Thaipusam match, so don't have?
Didn't go for temple for prayer, man.
No,
Okay.
can one.
So what time do you want it on Tuesday?
Normal lah, 3. No. I will tell you as soon as possible, che.
Okay.
Okay. I'll tell you by tomorrow or Sunday, che.
Okay.
Okay. Yeah.
So parallel to the axis. Okay. Parallel to the axis. After that, pass the reflection will go through the principal focus. So these two are supposed to be parallel. So the image is at infinity. Image is at infinity. That part there. Sorry. It should be there. Right? Image is at infinity. Virtual. Virtual, that means you cannot get it on the screen. Magnify. Don't think it's inverted. Let me just check. I think it's upright. Why do I put inverted? Why do I put inverted? It should be upright. Can remember or not? Inverted or upright? Yes, no. Okay, I think your book say inverted. Let me put a question mark. I think it should be upright on this side, not on this side. Right? Not on the inverted this side there. Okay, anyway, that's your homework for you to check. For me to check also. Let me just put a question mark. Okay, my view is it should be upright. Not inverted, but upright. Can remember ma? Your SPM work. Anyway, as I say, is you can check. Okay, where do we use it? Telescope. Right? Telescope or that eyepiece or telescope, that's your eyepiece. Formation of image by lens. Right? Now we are looking at the object placed less than the focal length. That's your focal length. Right? Less than your focal length. Sorry, didn't remove this one. Okay, that's your object. That's your lens. That's your principal focus. So as I said, the easiest one is to use the one that passes through the center of the lens. And the one parallel to the principal axis. After it goes through, it passes through the principal focus and produce it backwards there. Image is virtual, upright, and magnified. Use a magnifying glass. Okay. Any comment? These are all your SPM work. Ken? Anything you want to ask?
No, so far not sure.
Okay. Formation of image by lens, where your U is at infinity. Right? That's where you have your telescope. Right? Object at infinity. As I say, you just draw the line roughly. And then same can pass through the ray, the two rays are parallel, pass the principal focus. After the principal focus, you will go parallel. That is where you locate, where it cross, that is where your image is. Image is at V, right? That means the image is at the principal focus, right? Or the image distance is F, on the same side as the object. Should be opposite side to the object. This is your object here. That's your image there. Sorry, I don't know why I'm so careless. Okay. Right? On the opposite side to the object. Right? The object is there at infinity. The image should be here. Image is real, inverted and diminished. Right? That's why you can use your magnifying glass there and focus the sun ray onto a piece of paper. And you put it long enough, you should see it should burn. The paper should burn. Right? There's this case where the sun is at infinity. Infinity means very far away compared to the radius of the lens. Used in the objective lens of a telescope. Okay, so far? We are just reviewing your STM work. Right? Concave lens or diverging lens is very simple, very straightforward. Sorry, let me just remove the very careless on me. Okay, as always, this is the easiest one. The one that passes from the top there of the object to the optical center there. And then the one parallel, right? After that, it appears as if it's diverging from the principal focus or the focal point. Okay? Then you just draw the line, draw the diverging ray. Okay? See if it's coming from the principal focus. Right? Image is virtual. If it's on the same side, it's virtual. Virtual means cannot. You put a screen here, you cannot see anything. Upright, diminish, always smaller. On the same side as object. Okay. On the same side as object. That's your image. Where the two rays cross. Where the two rays cross there. Blue one and the black one. And there's your image. Right? Nothing much about that. For concave lens, very simple. Any comment or anything to ask?
No, sir.
Okay, I make a start. Lens maker's formula. After that, we will stop. Page 139. Right? Same as before. There's your lens. There's your U. There's your object. This is your image. N1 is air. N2 is a material, the medium or the converging lens, the glass. And then the surface, this one is R1. Right? The radius of curvature is R2 here. Right? So R2. Right? As I say, just imagine as if that surface is the surface of a sphere. That surface is the surface of the sphere. And that is your radius of the sphere. O is the object. I is the image in the medium or refractive index N1. A convex lens has a refractive index of N2. N2 is greater than N1. Radial curvature of the first and second refractive index is R1 and R2. Okay, as can be seen, this one is curvature, radius is R1. This one is spherical surface, radius is R2. Assuming the lens are thin, right, that means the thickness is negligible compared to U or V or compared to the radius. OB, right? B is actually the center we like, right? But as I say, we cannot draw very thin, and you won't be able to show you. Right? So B is practically, B and D are particularly the same point at the center there. Okay, U is your, so OB is your U. BI, okay? Because your reference on this surface there, BI is your image distance. Okay, so let's look at the first surface there. Right? That surface. Forget about this, the other surface. Right? Remember, we are not looking at mirror. We are looking at lenses, so don't get too confused. So this is your N1. This is your N2. Right? The surface there, that is glass there, reflected in there. N2. That's your object. That's your pole. That's your object distance, U. Right? And then the ray from the object, after passing through, will converge here to the image here. And that is the formula that we are using. Okay, so let's put into the formula. It's already there, right? N1, U, and then N2, V, right? But we have to use this. This is the image V1, right? So we put U is still the same. V1 is the image, right? By this first reflecting surface, and N2 minus N1. So this one we use R1. R1 is from the center here. That's the R1. Okay, then we look at the second surface. Right? Second surface, remember that's the second surface. That's your object. Right? Same, we are using the same formula, but we need to know how to interpret. This is your N2, this is your N1. Right? I1, right? This is I1. I1 is a virtual object for the second surface. Right? There's the image from the first surface there. So now this becomes a virtual object of this surface. So we have to rewrite that. Right? There's your V1, there's your V. So since it's virtual, right, it's not on this side. This side is where the ray comes from. It's on this side. So the object becomes negative. Then the final image distance is V. That's the final image distance. Right? Put into the formula. Remember your N1 is now N2. Right? U now is your V. That's your U. Right? Minus V1. Then N1 is now your this one. This is your second layer, N2. Sorry, your N2, which is now here, is now N1. And then that V is still the same, that V. And N2 minus N1, R is just R2. Right? That radius there. So combining our two equations that we have derived. Okay. We add the two together. Right? We add the two together. This one will go off. Okay. So we still got this one left and this one left on this side. On this side, we just add these two together. Then we take our N1 common factor out. This one is 1 over U, 1 over V. Right? This side, common factor N2 minus N1, N2 minus N1, take it out. So they become R1 plus R2. Okay. Dividing by N1, 1 plus U plus 1 over V equals to N2 divided by N1. So this becomes 1. So that's the third equation. And we can go to rays coming from object at infinity. Right? If it's ray coming from object at infinity, then your U will be infinite, will converge to the focal point. Right? That's the definition that we use. Right? Object at infinity, the image distance will be the focal point. Put inside the formula there. Okay, so this one becomes 1 over infinite is 0. V becomes your F. Right? This one still stays there. This one still stays there. That's why we get this formula. Then 3 and 4. 3 subtract 4. Okay, 3 subtract 4. Right? Remember, this is your 1 over F. Right? This one will, sorry, I think it should be, have I done something wrong here? 3 subtract 4. 3 subtract 4. Have I done something wrong here? Sorry. It should be 3 divided by 4. 3 divided by 4. Okay. 3 divided by 4. Right? 3 divided by 4. That one will go off. This one divided by that one equals to 1. Okay, that's how we get this formula. This is called your thin lens formula. Okay. I'll stop here. Since you no point in going further, then you should be, the more we study, the more homework you have to do. So I think I will stop here. Anything else you want to ask? Anything not clear?
No, sir.
If not, we will end the class here. So I see you on Tuesday. You'll confirm the time with me.
Yeah, okay, sir.
You don't want the class tomorrow?
Yes, sir.
Huh?
Yes, teacher.
You are going to have a class on Tuesday and you are going to have a class on Friday again. Where got the time to do homework? Anyway, your choice, you can think about that.